8 chemical quantities, and we're going to be looking at something called the mole. We're going to be using dimensional analysis again. We're going to take this very step by step. If you didn't get it the first time, hopefully you'll get it really well the second time. We'll be back to using significant figures, and we'll be looking at some key scientists that developed this concept of something called the mole. Now, as you already know, substances can be measured in different ways. We can count 5 apples. We can also use a term to group things together, like a dozen eggs. We can also weigh things. We can have 21 pounds or 2 pounds of bananas, 16-ounce box of cereal, and so on. So we can count things, we can weigh things. We can also measure the volume of something, like a gallon of milk or a pint of cream. So we've got different ways we can measure substances. We can count individual parts of the substance, we can weigh the whole of the substance, or we can figure out how much space or the volume that something is going to take up. The mole can be related to each of these types of measurements. The mole is kind of a really neat universal unit of measurement. We can actually use a mole to calculate the weight of something. We can use a mole to calculate how much space something is going to be taking up, and the other way around. A brief history on the mole. Avogadro in 1811 was an Italian scientist who studied the behavior of gases. He theorized that the volume of a gas at a specific temperature and the pressure contains equal numbers of atoms or molecules regardless of the type of gas or the nature of the gas. There's a picture of Avogadro. I don't know why it's such a strange picture. It looks like he's got a huge forehead, huge beady eyes, and a teeny little almost non-existent chin, but that's Avogadro. Lockschmidt in 1865 estimated that the average diameter of the molecules in air and was able to calculate the number of particles in a given volume of gas. So we're starting to get this idea of if we have a certain number of particles, we can actually tell the amount of space that they're going to take up. Millikan in 1910 measured the charge on an electron. From the charge on a mole of electrons, he divided the two and obtained something called Avogadro's number. Here's Mr. Millikan. Perrin in 1926 earned the Nobel Prize for computing Avogadro's number using many different methods and named this constant in honor of Avogadro. He used oxygen as a standard and proposed that Avogadro's number is the number of molecules in exactly 32 grams of oxygen. The standard was later changed to carbon-12 isotope, so now everything is based on carbon-12. Presently, the accepted definition of a mole is the amount of any substance that contains as many elementary entities or particles as there are in 12 grams of pure carbon-12. So we're basing our measurement off of carbon-12. Remember, carbon-12 is an isotope. So it would be a carbon that has 6 protons and 6 neutrons. The mole we're going to abbreviate as little m-o-l as a unit in chemistry serves as a bridge between the atomic and macroscopic worlds. Atomic is something you can't see. Macroscopic are amounts that you could see with your eye. In Latin, mole means huge pile. And you'll see when we calculate the size of a mole, it really does mean huge pile. The mole equals 6.02 times 10 to the 23rd. 1 mole equals that many of something. This would be like 1 dozen contains 12 eggs. This could be 6.02 times 10 to the 23rd atoms. We could have a mole of molecules, which would be 6.02 times 10 to the 23rd. We could have a mole of formula units, which would mean we have 6.02 times 10 to the 23rd. This means this many zeros. A mole is a huge amount of something. Because we're talking about microscopic things, the amount of space that these take up would be relatively small. This is 602 sextillion of something. This equality can be used as a conversion factor to convert particles into moles or moles into particles. This will be a one-step conversion. Oh no, here it comes again. It's dimensional analysis. We're all back to knowns and unknowns and the use of units in all the problems and canceling out units to arrive at the solution. We're also going to be talking about significant figures. It's all coming back together to haunt you just like we said it would. Example. How many atoms are in 1.22 mole sample of sodium? Well, we know that the question is giving us 1.22 moles of sodium. Our unknown is how many atoms of sodium. Remember, the known stands, or the K stands for what we know. The U stands for what we're solving for. So let's take what we know and put it over the number 1. Notice how I'm also including the units in this. We're going to multiply this by our mole conversion factor. Well, we've got moles on the top right here, so we're going to need to put moles on the bottom here. Here's our Avogadro's number, 6.02 times 10 to the 23rd, number of atoms in a mole of sodium. And then we cross off our units. So we're left with atoms of sodium, which is what we're trying to solve for, atoms of sodium. Well, you put this through your calculator and you'll find that this equals 7.34 times 10 to the 23rd atoms of sodium. When you use this format, and you'll see that in our practice, I've got actual boxes for you to write each part in, it becomes very easy to solve these dimensional analysis problems. Here's another one. How many moles are equal to 4.79 times 10 to the 24 molecules of carbon monoxide? We know we're given the amount of molecules of carbon monoxide. We're asked to find out how many moles of carbon monoxide. The first step is to take our known and put it over the number 1. Then we multiply that by our mole conversion factor. We're going to have molecules on the top, so we need molecules of carbon monoxide on the bottom. And then it'll be how many molecules are in 1 mole. Make sure our units are crossing off, so we're left with the unit that we're trying to solve for. And our answer is 7.96 moles of carbon monoxide. That's it for our notes for today. You're ready to go on and move on to the practice sheet. The practice sheet, you're going to do the odd-numbered practice ones, and then we'll give you a quiz on the even ones. You cannot do the even ones with your partner or unless you're sitting there to take the quiz.